Now that we know the basic understanding of linked list and how the singly linked list will actually look like, let's just get started with the implementation of singly linked list by setting up the structure for implementing the node that we have in the singly linked list implementation. Basically, singly linked list is nothing but collection of nodes, right, in which each and every node is connected to the next node. That basically means that in whatever the singly linked list that you see on the screen, right, this is one node, code is another node, true is another node. Likewise, each and every value is a node in which it has the value and it also has the connection to the next node that it is connected to. When it comes to the tail node, right, which is nothing but the last node that we have in the singly linked list, it is not connected to any other node. After observing this singly linked list, any node that you define in the singly linked list basically should have two functionalities. One is to store the value that user wants to store as part of that node, and the second functionality is to store the reference for the next node that it is connected to. Okay, using this next node we will be able to go on to the next node. As a result, we will be able to reach till very last value we have in the case of singly linked list implementation. That's the reason why keeping track of this next reference is absolutely important in the case of singly linked list or any type of linked list implementation. So we have to make sure that whatever the node structure that we are defining has the capabilities to store the value and also store the reference for the next node. Okay, one thing that you have to remember here is, since singly linked list is a heterogeneous data structure, we should support all type of data storage. That basically means that I may want to use some numeric value, I may want to use some boolean value or some other floating value as well. Okay, so ultimately whatever the type of value that I want to store in a specific node, basically each and every node should support that heterogeneous data storage as well. Okay, so that is something that is very important once again as part of value functionality on a singly linked list node. So out of the box, no programming language will basically provide us this kind of structure, right? So we have to write our own class to represent the node that we have in the case of singly linked list. So for that, what we will do is we will basically define a class called node. Okay, in this class called node, basically we need two things. One is value and the other is reference to the next node. That's the reason why we will define two variables called value and another variable called next. Here value variable is basically used for storing the value of the particular node, and next is basically used for storing the reference of the next node that particular node is connected to. Okay, so this is the structure that we will be defining. But in my singly linked list implementation, right, I keep on adding more and more values onto my singly linked list. That basically means that I will keep on adding more and more nodes onto my singly linked list. At that time, basically whenever I create the object of this node class, I am going to assume that I will not worry about this next condition, but based on the functionality that I will implement. Like I mentioned, we will be implementing push, pop, shift, unshift, various other sorts of implementations, right? So I will basically worry about adjusting this next pointer, basically reference of the next node in those specific functionalities. But when I create the object of this node class, I will only worry about taking the value from the user and storing that value as part of this node. For that, basically what I will do is I will create a constructor. So this whatever the constructor that I'm going to define, it will basically take the value from the user, and whatever the value that user passes, it immediately assigns to this variable. So immediately we will define a variable, value variable that we have, right? We will add whatever the value that we get to this specific variable. As I mentioned, at this point of time I will not worry about adding the next node, right? That's the reason why whatever the next that I have, I will simply assign null to this. Okay, once again I'm mentioning, when I go ahead and implement the respective functionality, I will make sure that I'm assigning the appropriate next node from the node that I'm adding at that functionality implementation. So don't worry about this at this point of time. Basically when I implement those functionality, you will basically understand how these next is getting assigned with the appropriate next node. Okay, so only thing that we have to worry here is we will define a class. In this class basically we have two variables, one is value and the other is next, and to add the value into the node object we basically added one constructor which takes the value and simply assigns that value to whatever the value variable that we have. Okay, so that is the structure of singly linked list node class. Now that we know this, let's go ahead and let's try to implement it. Now let me go ahead and represent the same thing using the Java. So far we have discussed arrays, and inside arrays we learned about searching and sorting and all these things, right? Now we are moving on to singly linked list implementation. So now what I will do is I want to put all these singly linked list ones inside a separate package. So I'm going to create a new class inside the package org dot coding pal dot singly linked lists. Okay, now we are trying to define the structure of the node. So I want to name the class as node. Okay, I'll simply click on finish. Okay, so as per our understanding, we tried storing the value inside the specific node and we tried storing the reference to the next node. So since it is a singly linked list, it needs to support the data of any type, right? So obviously in Java, if you want to store any type of data, the type of the variable will be object, because the object is the superclass for every class inside Java. So we will use the object type as the value that you want to store as part of the node. Along with this value, you also want to store the reference to the next node. Next node in the sense it is also again of the type node only. So what I will do, I'll simply take a variable of type node and I'll simply name it as next. So using this next variable, I'll be able to, from the current node, I'll be able to go on to the next node. From that next node's next variable, I'll be able to move on to the subsequent nodes till I reach the end of the linked list. Okay, now whenever I want to define an object, whenever I want to create an object of this node class, what I will do is I will take the value that user wants to store as part of this node and I will simply assign whatever the value that user has passed to the current object's value. Along with this, its object. Okay, along with this, when I create the object of current node, I will simply assume that there are no next nodes. That's why I'm simply putting this dot next equal to null. So this basically assumes that there are no next nodes inside the current node that we have created. Okay, but remember that when we actually perform the operations on singly linked list, we will adjust this next to the next node that we have. But at this point of time, just remember that whenever I'm creating the object of the node, I'm assuming that there are no nodes inside that in the next of the singly linked list. Okay, so this is how we exactly create the node object of a singly linked list.